Good afternoon. Today I'm going to talk about the maximum the efficiency and performance in utility scale solar system. And there will be three parts in today's webinar. The first part is overall solution introduction. So there will be an overall introduction of the PV system of utility scale power plants. And then after that will be some like communicating system introduction, how the system looks like in a PV plant of utility scale PV plant. And then we go to the second part, we go to the products inside the system, and then the monitoring system. So how the device cooperate with each other. And then the last part, we're going to talk about the case references we have for now from GoodWe. Let's go to part one. Let's see the overall solution, the PV system, utility PV plant. So this is an overall view of a PV plant. So it comes from the sunshine. The sun goes to the PV module, and then the energy goes from the PV module to the inverter. The inverter converts the energy to the AC power, and then we combine all the inverters, and then we combine all the inverters. So output goes to the transformer. So this is the transformer station. I will collect several string inverters from their AC output, and then I will do the voltage step up from, for example, in the system, the AC output of the inverter is 800 volts AC, and then it goes to the transformer. The transformer make the AC power up to like 35 kV, and then all the MV station, all the transformer station here, the output go through the MV switchgear, and then combined and goes up to the station level, like substation. So the substation here is basically another transformer, and then the transformer lifts up the voltage level from whatever the MV station output to the grid. For example, if the grid is 110 kV, so the transformer will go lift up the voltage from 35 kV to 110. So that's the energy flow from the PV module goes to the inverters, MV station, and the substation, and connect to the grid. So apart from this energy flow, we also have the information. So here, this one is the data logger. So the data logger will collecting the information of in the PV area here. So for example, this PV data logger, it's a communication box. The data logger connecting to the MV station on the LV winding of the transformer, as well as all the inverters are connecting to the LV winding. So they're connecting to the same like AC source, AC power. So that makes PLC, like power line communication, possible. So that's how the data logger collecting all the information of the inverters. And then the data logger also collecting information of third-party device. For example, here, the weather station, or the tracking system, or we say the whole MV station information, the breakers, open and close status, and other alarms and controls also be done by the communication box. And other than collecting all the information from the PV area, let's see this area, I will upload all the information it collects into the platform, to the PV station, PV plants platform. For example, we have like O&M platform, we have a SCADA system, we have PPC. So that's how all the systems, the logger giving the information to. So that's an overview of utility scale PV plants. And then this is an overview of how the MV station, or we say like transformer station, connecting to either each other, or how they are connecting to the substation transformer. So we can see if we have a big power plant and we have several MV stations. So here, this is one transformer station. We can see the inverters connecting to the LV switchgear, and then goes to the transformer, and the transformer connecting to the MV switchgear. So that's the energy flow, and this is a container. This is one MV station, and then this is the second one. This is the third one. So here for the MV switchgear, we normally use ring main units that make it available to be ring connected. So it's connecting to each other, and then finally the last one connecting to the substation transformer. And if there are some substations are far away from this, or it's hard to connecting to each other, or the cable will be longer, so it can be connecting to the substation like individually, or we say we have a small utility power plant. We only have maybe a few like megawatts. So one transformer station is enough. Then I will be like this on the right of my the screen. And then it's the overall solution of the community part. So this is the communication. This is the main communication device, which is the communication box. We called it SCU 3000 or SCU 3008. So this stands for Smart Communication Unit 3000. So because it's a third generation product already. And then between different communication box, we can support like fiber ring network, the ring connection. It will be like more reliable and safe. And then from the left part is the data, the information can collect from the PV area. Of course, we collect them from our inverters. In utility plants, it will be 350 inverters or our like classic 250 inverters. And also some third-party device. We see weather station, tracking system, or we say the transformer station. So the protocol here mostly will be Modbus RTU. And then it will also upload all the information to the upper like platforms. We see here we can see the SCADA system, or maybe PPC, or our own system. Like we have also system set called SolarOS. So that's all the upper platforms that can receive the message from ICU 3000. So here the protocol can be IC104 or Modbus TCP. So by this new generation of the ICU 3000 communication box, we have like more protocols we support. We also have more ports integrated. We have some digital input, digital output, more ports than the second generation. So it will be compatible with more third-party device. And then it will be faster. Together with SU 3000A and UT series 350 inverters, it will be, the communication can be HPLC, which is the next generation PLC of the classic one, and it will make the control and the communicate faster. For example, for the reactive power control, it will be done in less 30 milliseconds, and for active power, it will be done within 80 milliseconds. So right now we are familiar with the PV system of a utility PV plant. We're going to dive into the products, or we see the device inside, and we see how they work, and then what features that they have, and how they cooperating with each others. First of all, this our newly released product, the UT series. The UT series, the maximum power output power is 350 kilowatts. The power range of our UT series is 320 to 350 kilowatts. The DC current input can be either 15 or 20 ampere, depending on your module choice. For example, you're choosing your PV module. the current is 14 point something, you can choose this 50 ampere module of our inverter. So for with these two modules, our inverter will be compatible with most of the PV modules in the market. And then UT series also have the faster communication. As I mentioned before, it have this HPLC, which is the higher like frequency PLC is better, faster, and more stable than the last generation. And then we support a maximum of 400 millimeter square millimeter diameter AC cable. And also we have type 2 SPD integrated on the both DC and AC side. We also have IV diagnosis. So it will scan the IV curve of each string, and then it will diagnose if there's any fault happening on the all the panels and which string is happening. Also, we can produce reactive power, whether during the daytime, we can receive the comment from the SCADA system PPC, telling us how many reactive power should we generate, or we can do the reaction power during the night. And then the UT series have a higher European efficiency. It's like 98.8%. And then we also have a higher protection level. We have IP66, and also we have C5, the correlation level. And then the last one is a PID solution. So our PID will be optional. If you choose the PID function, then you can have both PID recovery and anti-PID on your inverter, on your module. It means that you can choose to enable the anti-PID during the daytime, and then you can choose to enable the PID recovery during the nighttime. So if you want the PID function always on, so during the daytime they do anti-PID, during the nighttime they can do PID recovery, or you can just enable just one of them and they do it like either during the daytime or either during the night. So that's more flexible for the PID solution. And then so this slide shows the most classic one we have for utility scale. So we have this one have been in the market for a long time, and then lots of customers are using it. We have also been receiving like good feedbacks. Most of the features like the last one, the UT series. So the HT series, the maximum power is 250 kilowatts. The power range is from 225 to 250. And then we have 15 or 6 MPPTs. We also have 2 modules to be compatible with the different PV modules. And also, so for this solution, the PID solution might be slightly different because it will be a standard PID recovery, and then if you want operation, you can optional to choose the anti-PID instead of the PID recovery. So that's the slight difference between our UT series and HT series. And then this slide shows a comparison between our HT series and UT series. As we can see, the first difference is the PLC communication. For the old PLC, it's a narrowband PLC, and then for our HPLC, it have a higher frequency, so it will be faster and more stable. And then the PID solutions for 250, you will choose either PID recovery or anti-PID. You have only one solution. And then for 350, you can, if you want PID, then we give you both, and then you can choose by yourself when do you want to open it, close it. And then for the derating, temperature derating performance, we always have our better performance on temperature derating. We have a nominal, as we say, 350 at 40 degrees. And then we have 320 at 45 degrees Celsius. So it's still not much derating. And for our 250, It will be nominal at 40 degree and then 225 at 45. And for the UT series, we have more MPPTs. So it will be, for the tracking efficiency will be better, and then will be more accurate doing the MPPT tracking. And then, of course, for the SCR, the higher output power, the UT series have a lower SCR. And this is how I said before, we can be compatible with most of the modules in the market. As we see, for example, you have 182 millimeter cells of your inside your module. So it makes the output current, let's say it's about 14 or 14.7 maximum. So when you have that module, you can choose the maximum current 15 ampere per string of our inverter. So this version of our inverter will be better for your choice of the PV module. And then if you're choosing a higher one, like higher power output of a single piece of the PV panel, we say, if, for example, you have a 210 millimeter cells inside your PV module, you will have an output about like 17, 18 something. So you can choose our 20 ampere version of our inverter. It will be maximum input 20 ampere per string. So it will be better for your like high power module choice. And then on top of that, we also have some features that may be optional. For example, this one is the intelligent DC switch. For our UT series, it is optional. So with this intelligent DC switch, I will finish the fuseless design. Because for our UT series, the maximum strings per MPPT is 2 strings. So we will have the fuseless design anyways. And then it is intelligent break and arc extinction. So for example, if the DSP, the control board, they detecting some fault current, fault voltage happening on the string, so it will give the commands to this DC switch, say that please open, and then cut down the faulty strings, cut off the faulty strings. So that's what the intelligent DC switch will do. So that it is directly controlled by the DSP. And then other features, for example, we also have the PID solution. So for the PID recovery, it will be apply a reverse voltage from like 500 to 800 volts between the PV negative to the ground. So that's how the PID recovery doing. So that's why it's just doing during the night, because it have to add this revised voltage. And then we also have NG-PID, so we can do it during the daytime. So what does it do is to lift the PV negative to the ground, make it just slightly over 0. So that's how it prevents the PID even happening. And I will give about 6 to 8 volts from the PV negative to the to the ground. So that's how the NG-PID do. For our PID solution, different from other other suppliers, so we do put the PID boards, the PCB boards inside the inverter itself. So it will be an internal device. You won't need to have any additional device to fulfill the PID solution. And then here's some product highlights. So let's make some conclusion for our inverters. So we are compatible with big current modules. So that makes whether which module you're choosing, we will have the right version of inverter for you. And then we have SAR, lower SAR. We can have reactive power generation during the night. We can do the PID solutions. We have an optional intelligence like DC switch. We have HPLC communication, which is faster. We have a protection level at IP66 and C5 for the correlation level. And then we have a better temperature derating performance. And next is the next product from our company. So we basically provide the whole solution. We provide all the devices you need in the PV area. So this one is the transformer station. So we called it MES. So this is a compact structure. All the device will be integrated into this 20 feet standard 20 feet high container. And we divided into 3 parts. We have the MV room, which will be the MV switchgear and the auxiliary device. For example, the UPS, auxiliary transformer, and the distribution box, and so on. So that will be in the MV room. And then in the middle is the transformer room. Will be, of course, the transformer. And then here on the right side is the LV room. Will be the LV panel, the LV switchgear, and also I think our monitoring and control unit will be located here. So for the transformer station, it will be pretty much customizable. You can choose because everyone have their different designs for the PV utility PV plant. You can have different output voltage level. Maximum can be 40.5. And then the total power, output power can be a maximum of 7 megawatts. And also, for example, for 7 megawatts, you will do a double split transformer. And then if you, for example, 3.5, then you will have a double winding, just 2 windings. And then here in the MV room, we have the MV switchgear, we have the RMU. It's quite customizable. You can choose, for example, here they said like CVC, or you can choose the DCV, whatever you need, whatever you want. If you only have one subarray, you only need one MV station, you can only have 2 switchgears inside. And then all the device will be pre-installed, and all the cables will be pre-connected. So once this device is on site, the only thing you need to do is to connect the LV cable and the MV cable. And then in the factory, we also will test and do the communication, like the pre-commissioning. We can see that all the signals, all the controls will be tested before. And then for the protection, the whole container is IP54. And then for the transformer itself, it's designed for outdoor use. It will be IP65. And then for the efficiency, we can do like European standards, maximum 99.58% for the efficiency, or we can do lower depending on the cost. And then we comply for the Europe standard as well as the international standards. We have IEC 60076 or IEC 62271. A lot of test reports, certificates. And of course, to get this certificate, we have to do the tap test in the lab. Additional to this, we also do some simulations. We did like wind load and snow load. We did the shocking. We did the vibration. So, for example, we can withstand a wind load of 1720, and then the working temperature will be -30 to 60. And this one is another product. It's called SolarOS. So it's so we develop our maintenance and operating platform. So this is a node element platform. You can do it use it with our data logger, with our inverter, and then you can do pretty easy O&M. We have you can generate your report, and then you can do the inverter upgrade, the data logger upgrade. I mean the firmware, and then we can do the IV diagnosis, and then we also do some analysis. We see how's your plant's performance, whether it's doing good, how many power is generating, is it a good level or not a very good level. So we can see here it shows the menus. We have the station wheel. It will generate based on your map, your plants. So that's pretty simple to see what your plants exactly look like, how it looks like. And then we have analysis, we have equipment monitoring, and also the most important, we have the alarm management. We have all the alarm, and then we have a report, and then the protocol, the big data analysis, subarray, and then we have the device management, and also we also have some like user configuration, something like that. So on this platform, SolarOS, we're able to do the IV scan or like IV diagnosis together with our data logger, of course, because they have to get more data from the inverters. So it will generate IV curve like that. So IV curve and PV curve, and from these curves, it will it is AI, and it will detecting failure on the PV panel. For example, if these panels, if it have some shadow, have open circuits, small cracks on this panel, and it will diagnose us from the current and voltage level, or we can see this PV curve, and then you will be notice that where exactly the string the panel, the faulty panel in. And so the diagnosis is pretty simple. You can done it just by one click. The diagnostic time is also really fast. For 10 megawatt station, it will be less than 10 minutes. And for a 100 megawatt station, it will be less than 30 minutes. So I think that's all for the part 2. We talked about different device, different products. We talked about the SolarOS, the O&M platform. We talked about the transformer station, the inverters, of course, also the communication box, and how they cooperate with each other, how they fulfill the functions, how they works in the PV system. So next, let's see some case references from GoodWe. We're using the HT series, or we see UT series. So this is power plants in the water, and it's 50 megawatts. So we can see this inverters are our UT series. And this one is 30 megawatt PV plants in Malaysia. So this one will provide our whole solution. We have our MV station, we have our inverters, we have our data logger, we have other third-party device even provided by us. And this is our like HT series. And then the next one is the rooftops. So we're not saying our UT series, but at least our HT series, HT225, HT250 are also compatible with big rooftops like this. And then we can see our plants in the water rooftop, and also we can see it in the desert. As here is a plant, and there's our HT series. And then also in the mountain, so it's a 60 megawatts PV plant. So this one is also HT250, is the classic one. Okay, I think that's all from today's my sharing.
Okay, and the next part would be the Q&A section. If you have any questions, you can post them in the Q&A box. And we already have some questions. The first one is, what about other modules rather than the one we recommended in the webinar? Is the 180 and the 210 millimeter modules?
So other modules, more or less, they will be earlier modules from earlier years. We have, I think, 166 before in early years, and that will only make the current lower. It won't be more than 15 ampere. So the 15 ampere will be compatible. You can just choose the 50 ampere version if you have other. And then, for example, other modules, we have different ways we have different ways to have different kinds of modules. We have P-type modules, we have N-type modules, we have film modules. We are all compatible with all these modules in the market. So most of the modules you can choose our inverter. You just need to choose the right version. There will be the right version, anyways.
And next one is this. Is this solution a turnkey solution from GoodWe?
Yes, that's more or less the utility turnkey solution. We have the whole thing here, and then we provide the whole solution to different customers.
And if anyone is interested in the salesperson contact, please send a message to the Q&A box, and I will send the corresponding person the contact info to you after the webinar ends. I will send it from your email. And the next question, do you have any example pictures of monitoring for the RV diagnosis?
So this one, I think I have some, maybe in the, can you left your email, and then maybe after this webinar, I can send you some example pictures to you.
The next question, is the data safe if there's any emergency alerts?
So in some market, you can check with yourselves. We provide some third-party like vertical equation device, and then but that one, or there should be another one on your let's say the PV the plant level sides. These two have to be corporate switched with each other. So sometimes we don't provide it for all the markets, and also we can locate our a service locally. We can just use the internet. Not we can use private internet, not the public one. So that's how you keep your data in your plants safe.
And if anyone's interested in the copy of the presentation, you can also leave your email and your request, and we will also send from email after the webinar. And the next question is the NB station available in India market?
I think yes. I think it will be available in India markets, although we haven't shipped there before because the transformer India like you have domestic transformer provider, and then it will be, I think, maybe cheaper for your overall solution if you want to plant in India.
And next question, do you have a real-time monitoring system which capable in monitoring different brands of data loggers?
So for now, our real-time monitoring system, probably SolOS, we're not compatible with other brands of data loggers yet because the protocol between our data logger and the platform is our private protocol, MQTT.
And next question, can I ask the secondary voltage for both 250 and 350?
So for this question, for both 250 and 350, the AC output is 800 volts. The DC input is 150, 1500 volts. The DC input nominal, and then for the AC output is both 800. So that's why our administration, the transformer, is from 800 to something like 35 kV.
Next, what is the biggest capacity for the inverter module and how many PV module can include?
What is the biggest capacity? I'm not sure the biggest one, but I think anything, I can give some examples. So maybe 680. I think I've seen that. And how many modules, it's hard to calculate, but for our inverters, we can do, I think, 1.5 the DC over AC ratio. So that will be 1.5 times 350. So that's, you can connect some maximum 500, more than 500 kilowatt PV modules on the DC side.
And the UI of the diagnosis, we will also send you from email. And next question is UT series available in India?
So that will be second half of this year. I cannot recall the exact time for every market, but we are doing the certificates and the grid code, the firmware, country by country. So by the latest, it will be end of this year.
And we have a question from the chat. Given the 100 megawatt solar farm, how do we divide this on per ND station?
So it depends on how many inverters you want to be connecting in parallel. For example, we don't recommend a lot of inverters connecting to each other in parallel. So that will make the harmonic out of control. So we recommend no more than 14 of them connecting in parallel. So 14 of, as an example, I see HT250s. 14 of HT250s will make 3.5 megawatts. So that's a single winding of the transformer. And then we can maximum do double split. So we have 2 LV windings. So that makes a maximum of 28 inverters per MV station. And then if you have 100 megawatts, you can just 100 divided by 7, and then that's how many MV stations you have. Or we see 100 divided by 3.5. That's how many PV array you have. That's how the inverter in parallel units, you have a single unit, 3.5 megawatts. That's the maximum recommended.
Will the HT series be discontinued, be off market after UT series is launched in all markets?
For this question, I think no, at least short time, at least 2 years, because HT still have its own like scenario to use to be compatible with. Of course, in some plants that UT series will be lower cost, but in some special plants, we cannot say if the higher power inverter bring the lower cost or the longer cable bring the lower cost. So it will be quite a decision for the plant owner to choose which one is best for her. So that's how we decide. We were not going. HT will be still in the market for at least like 2 years, and then we will see how the market goes, and then we will see if we have some new versions of inverters.
Okay, that's pretty much all the questions we have got for now. If you don't have any other questions, and that would be all for today's webinar. And thank you for your time. We wish to see you in all the other sections of our training webinars. Thank you.
Thank you.